Hi, we have the AP Physics 1 past paper 2021. We are discussing free response question section. We have the question number 4, which carry the 7 points. In the question, a cylinder of mass m0 is placed at the top of an inclined length L0 and the height h0. Mean the total inclined length is L0 and the height is represented by h0 as shown in a figure. Released from the rest, the cylinder rolls without slipping without on down the incline and then continue rolling along the horizontal surface which is also of the length L0. On a grid below, sketch a graph that represents the total kinetic energy of the cylinder as a function of distance traveled by the cylinder as it rolls down the incline and continue roll across the horizontal surface. Okay, this is the provide grid. So I have designed the potential energy at the height of here. When the cylinder is at the height, it is at the rest position. The wholly solely energy is potential energy. Okay, when it is start to move, the potential energy start to convert it into kinetic energy. Cylinder rolls without slipping, so the incline is straight. Height decreases linearly with the distance, so total kinetic energy linearly increases with the distance. On reaches the horizontal surface, there is no potential energy further loss, so kinetic energy remains constant. So this is the version in initial as kinetic energy, potential energy is decreasing linearly, kinetic energy is linearly increasing. At reaching the horizontal surface, there is no loss of potential energy, so there is constant kinetic energy is there. Okay. The cylinder again is placed at the top of the incline. The block or also of mass m0 is placed at the top of a separate rough inclined length node. Now the surface is rough. Length is L0, h height is h0, same as previous case, but in this time the surface is rough. When the cylinder and block are released at the same instant, cylinder begins to roll without slipping while the block begins accelerate uniformly. The cylinder and the block reach the bottom of their respective incline at the same translational speed. This is the key point. This is the question. Both reach the bottom at the same translational speed. Now, in terms of energy, explain why the two objects reach the bottom of their respective incline with the same translational speed. Provide your answer in clear, coherent paragraph. Response may be contained figure or equation. Now, we have to discuss the both cylinder and the block start with the same gravitational potential energy, that is mgh0, because they are at the same height. Now, for the cylinder, rolling without the slipping means no energy is lost as a heat and because there is no slipping. Okay. So mgh0 is converted to translational and rotational kinetic energy. For the block, sum of gravitational energy is converted to translational kinetic energy. Rest is lost as a thermal energy due to friction. Okay. The problem states the two objects reach the bottom with the same translational speed, which means the energy lost due to friction by the block is equal to the rotational kinetic energy gained by the cylinder. Now, the step we have to consider the cylinder having the two type of energy, translational and rotational, while the block has the two type of energy. One is translational kinetic energy, one is thermal energy due to friction. Now, both have the translational speed same. The cylinder and the block have same translational speed, so they have the same kinetic energy because the mass is same. Now, rotational energy is equal to the energy lost by the friction. So the energy lost by the friction is equal to the rotational kinetic energy gained by the cylinder. Both are equal. As a result, block and the cylinder have the same translational kinetic energy, therefore the same translational speed at the bottom. That's the reason. Okay. And that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it. Okay, take care.